viewers, welcome back to a new video on AI World for You. In today's video, let us see one example of problem solving and discuss what is this problem solving in AI. So problem solving refers to the process of finding a sequence of steps or actions, we will call them as, which will transform the current situation, which is the initial state, into a desired outcome, that is goal state. So take one particular agent, it is at one position, it wants to go to the destination, which is the goal state. So wherever the agent is right now, the current situation, that is your initial state, and where it wants to go, that is the goal state, and the actions which it will take, that is the series of actions or steps it will take to reach the goal, those we will call them as actions. So these are some of the important terms involved in problem solving. Say for example, consider Sudoku. There we will go with a sequence of steps to arrive at the goal state. What is the initial state? However, the Sudoku puzzle is given to the user, that is the initial state. What is the goal state? That is the solution of the Sudoku. That is, we need to write the numbers 1 to 9 within the same square as well as horizontally and vertically, and see that no number is repeated more than once, right? So that is our goal state, and initial state is how the Sudoku puzzle was given to us. So whatever steps we take in solving this, those are called the actions. So the agent will perform the actions to move from initial state to goal state in the problem solving atmosphere. Let us see what are the components of a problem. The initial state is one where the agent is going to start, and the goal state is the one where the condition needs to be satisfied, that is the desired outcome. Then the actions are all the possible steps or moves that the agent can take to reach the goal. And the state space means it is the set of all possible outcomes, okay, all possible outcomes or all the possible moves which the agent can do to reach the goal. And the path cost means it is the numeric cost assigned to the path. Like for example, if you consider a traveling salesman problem, the fuel cost or the distance traveled by the salesman, all those will be considered in the path cost. Coming to the steps involved in problem solving, the first step is define the problem. Whatever problem is given to us, it should be defined clearly and precisely. And then we need to analyze the problem. And then we need to go for identifying the set of possible solutions. So after analyzing, we will get an idea about the problem. Then we need to go for analyzing and finding the solutions, identification of solutions. Among a set of solutions, we may feel that this is the best one. So we need to choose the best solution and then go for implementation. This is how the agent will approach problem solving. It will first define the problem, analyze it, identify the solution, and then choose the best solution and go for implementation. Let us consider one simple example. So here, this is my initial state where I have a 3x3 grid and I have the sequence of numbers 1, 2, 3 and I have an empty space here. Then 4, 6, 7, 5 and 8. Then I have one more 3x3 grid which is my goal state. So I have 1, 2, 3, 4, 5, 6, 7, 8 which is a sequential way the numbers are arranged in ascending order and the empty space is in the last. So this is my goal state. Now the agent wants to start from here and it needs to end here. So how will the agent approach the problem? Let us see step by step. In the first iteration, the agent will look for all the possible moves. So this is my initial state and I have a space here, which means the number 7 can go up, or the number 1 can come down here, or the number 4 can move towards the left. So there are 3 combinations and 3 possible ways in which the agent can take a move here. So all those 3 possible cases are listed here. If 1 comes down, then this will be the outcome. This is how my 3 cross 3 grid look when 1 comes down. Thus empty space will be created here. And suppose this 7 goes up, the number 7 goes up, then this is how my 3 cross 3 grid will look like. The empty space will be right here. And suppose this 4 moves to the left side, then there will be an empty space created here. And this is how my 3 cross 3 grid will look like. So among these 3 possibilities, now my agent needs to go for choosing the best solution. So as we saw, there are 5 steps in solving a problem. The first one is defining the problem. Second one is analyzing it. Third one is solving it. That is going for all the steps. And then finally we need to choose the best solution. So here, which is the best solution? Which is nearer to my goal state? I will choose this one because I have 4 numbers in sequence already. So I will choose this one. I will move 4 to the left side. So in the next iteration, we will begin with this grid. Okay. So iteration 2, I have this grid which was the best solution of the first iteration. Now from here again, I need to look for all possible solutions. I can have 2 coming down, or 4 moving right, or 6 moving left, or 5 coming up. So there are 4 different possibilities. I have listed out all the 4 possibilities here. So if I have my 2 coming down, then this will be the possibility. If I have 5 moving up, then this will be the possibility. If I have 4 moving right, this will be the possibility. And if I have 6 moving left, then this will be the possibility. Now, among this, which is the best solution? Can you guess which is the best solution? See, we want the grid to be sequential. So, this is the best solution. 1, 2, 3, 4, 5, 6, 7. We have already got up to 7 here. So, this is my best solution and the agent will select this for the next iteration. Now, iteration 3 will start with this state. So, from here, we have only 2 possibilities. That is, either 8 can move here, or 7 can move here, or 5 will come down. But already 1, 2, 3, 4, 5, 6, 7 are in sequence. And we know that if 8 moves to the left, we can reach the goal state. So the agent will look for the possibilities. Either 7 moving here, that is this case, and the 8 moving here is this case. Once the goal state is reached, it will not perform any further iteration. So since this is the goal state, the agent will stop its execution here. In a problem solving by agent, it needs to define the problem, analyze the problem, and list out the possible solutions and then choose the best solution and implement it. So the initial state, goal state and the actions should be known to the agent for maximizing the performance of the problem solving. We can consider many more examples like N Queen's problem, Wumpus World problem or Towers of Hanoi. There are many more AI problems which the agents can solve. I hope you got an idea on problem solving, and if you like this video, do like it and share it with your friends, and do subscribe to my channel for further updates regarding AI. Thank you for watching.